All right, we got lots of people rolling in, but it is time, so we're going to get started. Hello, everyone. Welcome to our next installment on the series of emerging technology in the federal government. Today, we're going to talk about GIS. GIS stands for Geographic Information Systems, and many of you use these systems today without paying much attention to it. When you visit a website that has a map on it that you can interact with, you're using a GIS system in some form or another. For most of our customers, GIS is used to analyze spatial data, and a few of the use cases that we've supported for the government consist of base facility planning, conservation planning, disaster management, and mission planning. GIS is a cornerstone of many of the operational planning systems in the federal government. Today, we're going to talk about modernizing these GIS systems. Lots of new capabilities have come online, and the government is moving on them pretty rapidly. So, with the influx of cloud migrations, containers, and artificial intelligence, there are a lot of opportunities for improvement around GIS. So, let's get started today by introducing the panel. I'm Paul Williams, Vice President of Solutions for Coney Ag Government Services. And now I'm going to let the team introduce themselves. Scott?
Hey everyone, my name's Scott Simmons. I am the Chief Standards Officer with the Open Geospatial Consortium, better known as the OGC, and I work with our 450 or so member organizations all around the world to develop standards and interoperability practices for all things geospatial, so to enable those GIS applications and capabilities that Paul just highlighted for you.
Thanks, Scott. Jeff?
Yeah, so my name's Jeff Demuth. I'm a solutions architect at AWS on our geospatial team. I've been with AWS for just under 9 years, and actually I've been working in the geospatial team for the last 7.
All right. Thanks, Jeff. Thanks for joining us today. Damien?
Hey everybody, Senior say on team with Jeff. We support Esri and geospatial on AWS. Glad to be here today.
Thanks, Damien. And Brian?
Hey everyone, Brian Smitches, Solutions Architect supporting our federal partners. So Coney Ag Government Services I work closely with, and obviously in the federal space, there's a lot of GIS type workloads. So happy to be here today.
Yeah, thanks, Brian. Thanks to everyone for joining us today. Just a little bit of housekeeping before we move forward. We're going to do this panel style, so our first interactions are going to be amongst the presenters. But we do value your questions. We believe it's a better webinar if we get interaction with the audience. So please post your questions to the chat. And once we're done with our initial run through, we will come back to those questions. So that being said, we're going to jump right in. So Scott, the first question is for you.
Sure thing.
In your exposure to both commercial and government GIS, you get a wide lens of challenges and customers that you see with GIS modernization. What are some of the emerging technologies and trends that you've recently seen with GIS?
Yeah, and I'm highlighting a couple of trends here that my fellow panelists are real experts in, because it's also critical to what's happening in the community. And I'll talk to two areas. One is in what we refer to as cloud native geospatial, the other artificial intelligence. When we talk about cloud native geospatial, that is, how do we format geospatial information to take advantage of those capabilities inherent to the cloud? So the traditional concept of us having just file systems on our computer, and you threw a few satellite images on there or a few shape files, and you did a little bit of processing, are sort of circumvented these days primarily by huge cloud data stores, massive quantities of information. If you look right now, the entirety of NASA's Landsat collection or European Space Agency Sentinel data collection are all available on the cloud, massive quantities of data. And so to do so, you need to optimize the way you store this information and make it available to users. So we look at standards under development are in place now, such as cloud optimized GeoTIFF. Everyone's worked with GeoTIFF for their satellite images, but now it can be indexed. It comes up faster through cloud access. GeoParquet, part of a Parquet ecosystem for vector feature data, roads, rivers, etc. GeoZar, another format which is used for data cubes. So that's a lot like your traditional big data stores. Some of you may be familiar with things like HDF5 and other ways to store massive quantities of spatial and temporal data. Now there's some cloud optimized technology through GeoZar, and then exposing all those data to analytics. So bringing the algorithm to the data. We don't download our data anymore and play with it on our personal computers. Ideally, we send our algorithm in a container out to the cloud, and it does all sorts of magic with these data stores. And so the scale of analytics and the entire provisioning and how you push your algorithms to different storage formats for these cloud native things is really a major area of work right now. Unfortunately, a lot of our ODC members have been very active in that, and we work very closely with AWS on a lot of these standards. So those analytics really lead to the issue of how we're working with artificial intelligence. We looked in OGC at the requirements of the community in the geospatial space in particular of what do they need to ensure that AI efforts are consistent and predictable. And we determine that it's on the quality side. So how do you determine how good your training data are? So we have developed a standard called training data markup language for artificial intelligence. I know it's a mouthful, but the training data standard lets you identify when you are sending a training data set to an algorithm, how do you describe that training data set for its suitability? So if I have an issue with a flood in an urban area and I'm using satellite image snapshots of urban flooding to train more analytics on that urban flood, that's not portable to flooding in a forested area. And so the difference of the source data for your training impacts how your AI works. And we want to have consistency how we describe that. What's that suitability, that fitness for purpose? And so that's just the two main areas where we're working these days.
Oh, that's great. Thanks, Scott. So a couple questions for you for the audience. What's a data cube?
Yeah, so data cube is, if you think you've got a data, let's go with a data square to start with, right? So you had a satellite image, black and white satellite image. It had some pixels and rows and columns and some values in the middle. Now just take a whole bunch of different layers of that and stack them up. So you might have your more modern satellite imagery that's 4-band colors, and each of those is a different layer. But then you might have those over time, and so you stack those with time. And you may be discovering other phenomenology over the same area. And so it's really that compendium of multi-dimensional data around any particular geographic area. And so these data cubes look at things such as stacks of satellite imagery, but equally important is meteorological data. So the weather data that an aircraft flies through is space and time and various values that are changing over time and as you travel through it.
Oh, great explanation. Thank you. So one more question about, you said cloud native geospatial. So what do you see as being the biggest aspects of the cloud aside from the availability of data? We know the availability of data is very important for the ability to do artificial intelligence or analytics, and also geospatial, which is kind of an extension to analytics, right? But what are some of the technology you're seeing? Is it cloud native functions, or is it mostly the ability to store such a large amount of data and make it available?
I think one of the huge advantages of cloud native is the hugeness, right? The whole bigness of the situation, the ability to have data stores that work on massive areas or massive volumes of data, including global data sets, so that you can work across that entirety of data in one operation. A great example is the United Nations has a committee on desertification of the earth, and they've been looking at how do you analyze the variety of data they have, be that satellite imagery, radar imagery, weather patterns, etc., across the entire globe, and have a consistent way to describe what areas of the earth are becoming more desert-like and which are becoming less desert-like. And so it's just that scale of operation, I think, is absolutely the biggest benefit we have right now.
All right, great. Thank you. Now we're going to move on to our next panelist, Damien. You've been supporting infrastructure for Esri and other GIS solutions at AWS for a while. What are some of the trends that you've seen?
So generally, like Scott said before, it's scale, right? So when I started this journey 10 plus years ago, it there wasn't much ability to do anything really, right? So large monolithic applications, you have a database, you have compute, and that's about it. The ability there was just to have the capacity to scale easily. So I could take a small compute machine and make it a little bit bigger horizontally or vertically, and then I'll get more compute, which was a little bit easier. As time passed, we realized that the scale started changing. More customers were getting into data and needing more compute, more storage options, and the ability to touch data across the infrastructure, or rather across the organization. And with that, we saw new emerging technologies, right? So there's been advancements in storage. So from S3 being able to cloud optimize images on the compute side, being able to run Spark clusters in things like Amazon EMR, databases now with zero ETL, so you can move data in between fairly easily. And then the new thing is kind of like big data, AI, ML, that has been around for a little while now. But there's been constant advancement in that kind of a pipeline. Recently, there's been updates to Amazon's infrastructure where you now have the ability to do things like SageMaker notebooks as well as EMR and then zero ETL pipelines into databases. So whereas you had like 3 separate workflows before, you can now combine those workloads and have data move through a really nice pipeline, and that's kind of all encompassed. That means now that we have data scientists being involved with using infrastructure, you don't have to be a cloud guru to get involved in using large data. A lot of it's been taken, like handled on the back end. You really just need to understand how your data moves. The other thing is the support ecosystem. So what we're seeing is platforms of platforms. So you have geospatial platforms like Esri building their frameworks, and then partners of theirs building on top of those frameworks. And then those frameworks in geospatial, so it's geospatial platforms, have to sit on an IT platform because there's the impetus to move to cloud across all industries, even the government as well. And go in there, what we're seeing is you really want to platform the platform. So you want to take your geospatial platform and put it on the IT platform. In doing that, you have to have support for these kinds of workloads. So you need to make sure that compute's there, available and scalable. You need to make sure that there's the ability to do things at scale, because really that's the huge benefit there, is being able to do this at scale. And then one of the last things that we're seeing as well is more regulated industries getting more comfortable moving in, where before it was kind of a no-no or like a bad word to say cloud. We're seeing people becoming not opening up a little bit. So more government service moving to the cloud, more regulated industries. So some of the larger utilities are starting to move most of their infrastructure into the cloud just because it's more, that ability to scale is there. So they're being more open towards it.
All right, great. So I got a couple of questions for you since you're infrastructure related.
Yeah.
So a lot of our government's clients need to do things like share large data sets with other government clients. What are some of the capabilities that the cloud brings that they did not have available in the data center when sharing these large data sets cross agency?
Yeah, so it's shared infrastructure, or rather shared platform. So in a data center before, you'd have to have some kind of connection between data center A and data center B, and then you're limited by transport across the network, right? So you either have a direct connect, or you run a fiber cable from one to the other, and then you try to transfer data, or you move data around. Like moving data was hard. But now because everybody sits on, let's say, S3 like AWS, because they're in essentially the same infrastructure, it's a lot easier to open sharing between one data set and the other, or having the ability to access S3 buckets.
So they can essentially use it in place now instead of having to move it, many
Yeah,
thousands of miles in some cases, right? So if you were sharing data between, say, NOAA and National Weather Service, you could easily integrate if you're in the cloud area.
yeah. If you're in the same data center or the same region, it's a lot easier to do that sharing. And also from a security standpoint, like you could also get really granular on what's being shared rather than just saying, here's all of my data. I could get really specific on what data is being shared and how it's being shared.
Right. And I think that really tees up the capabilities that we're going to let Jeff talk about now. So thank you, Damien.
Yep.
Jeff, you worked and supported AWS for a while. You're mainly focused on data and AI in GIS. So can you talk about some of those emerging trends and how the infrastructure, the changes, the movement to the cloud, and the adoption of AI is impacting the government clients?
Yeah, and actually to add one more point on to the previous question, there's a nice capability called requester pays with AWS. So I'll touch on it a little bit, but geospatial data lakes are getting more popular. When you get imagery and vector data into the data lake, when that's sitting on AWS S3, you can share that data. Some of these data sets are by requirement have to be shared publicly. And there's always concern of, well, who's going to pay for the data transfer? But on AWS, you can actually mark those data sets as requester pays. So the person downloading it, if they want, to pull down a couple satellite images, you can give them an option to do that free. If they want to pull down a petabyte of satellite image, you can basically tell them they have to go through the requester pays method and pay for the data egress to do that.
There's no government customer that I've ever worked with that did not mention the need for that kind of thing. So that's really great.
Yeah. And then, yeah, so Gen AI and geospatial, it's early for Gen AI and geospatial, but it's already been hugely impactful. I think we're gonna have a quick demo on one of them here after my talk, but we've also got some other demos we can do with SQL query generation, or I should say geospatial SQL query generation. Also, we've got a demo on RAG architectures that we can show with geospatial data. Esri's got a pretty neat demo they do with their survey 123, where you ask the Gen AI to essentially fill out the survey form or create the survey form. And then there's a lot of effort and energy being done to create natural language to map. Basically, build me a map, the data's over here, put everything together and visualize it. I mean, that's kind of the holy grail that everyone I've talked to is working towards. So some of the models that are out there, so we're seeing a lot of work in vision models. A good example is Clay. Clay has built a vision model. They took petabytes of satellite imagery, ran it through an embedder to tokenize the pixels. They've essentially taken petabytes of imagery and embedding that and tokenizing the pixels. They've brought that down to, I think it's a couple hundred gigabyte foundation model. So that model with that compression understands the entire world. You can say, where in the world do these features appear? And in a couple hundred gig model, it can come back and give you answers about that. It's really impressive. Also, at our reInvent a week or two ago, AutoCAD was up on stage. They just talked about a foundation model they built, natural language basically to create CAD models or 3D models. That's kind of a unique undertaking because language models and foundation models have been, vision, which is pixel based, kind of 2D pixel based, and then the language models. Those models are trying to predict the next character in a string, but with AutoCAD, that's 3D space. So they're working with a foundation model that's trying to guess, what the next object is inside of a 3D space. So it's pretty revolutionary.
So what's a practical use case of that?
So
just for
yeah,
everybody to understand.
you're working in like a geospatial 3D scene, and you wanted to add a house into that scene. You could say, draw me a 3D object of a house, or I don't know, some trees, or maybe a certain type of tree, or a road, or street lamps. You could basically build out a whole scene using completely using natural language.
Okay. So if someone wanted to put their house on like Google Maps or something like that, or Google Earth, they could use this to draw out their house and put it where it's supposed to belong, or maybe their dream house, right? From a consumer perspective. But I could definitely see some military applications with that too. One of the things that we supported is facilities planning. So I could see that being very useful to be able to draw out all the buildings on a base and then put them on a map.
Yeah, and definitely more relevant to, like architecture, engineering, construction, the AEC organization. But I don't know, maybe, in a building permitting type scenario, maybe you wanted to see how things are laid out, and how that on the geospatial side of it, are you going to issue the permit? What's that going to look like?
Yeah, it's moving very fast. It's very interesting how many different capabilities are coming along, and being able to talk to some, a chat bot to build you something is a pretty neat concept. So
Yeah,
interesting times.
yeah. And then so some of the other work out there too. So LangChain and Llama Index are seeing a lot of geospatial development, being able to create custom geospatial processing tools. So these foundation models, right, they're not good at math. They're not really designed to do math. And that's where these LangChain tools and custom tool development comes into play. So what a lot of these foundation models will do is they won't try to solve requests like that. If you say what solve this math problem, they'll actually take that request and route it to a custom tool to solve it. And that's very relevant in the geospatial world, because a lot of the geospatial problems that we're trying to solve are mathematical. They're not, it's not guess the next character in this text string. It's, I need an actual math problem solved. So having the agent, though, the foundation model, be aware that there are tools to solve these types of geospatial problems, take the parameters, organize them into the syntax that the tool needs the parameters in, run them through the tool, and then summarize the output. There's a lot of power there. And then having the foundation model just recommend tools to use to solve a problem. LangChain, so we actually wrote a blog and did a demo using natural language to build a map. That's how we developed it, was using LangChain or something like LangChain. I was working with one of our geospatial software developers, Pratik, super smart. Instead of using LangChain, he basically built his own custom framework, and it was essentially LangChain tools. So there was a tool to grab the data, there was a tool to convert the geometry in the data, and then there was a tool to create the, I think we used the MapLibre framework on that one to create the MapLibre JavaScript and load the data into it. And then the last point I was going to make is with RAG architecture, so retrieval augmented generation. Another challenge with geospatial is you've got data kind of spread out all over the place. If you start working on building these geospatial data lakes, we've got a service called AWS Knowledge Bases, kind of a no-code, easy one-click RAG solution. You can pull all that imagery metadata, all that vector metadata into a RAG database, and then ask the generative AI foundation models, what imagery do I have for this part of the world at this time? Or, where do I have satellite imagery that doesn't have clouds in it? Things like that.
Yeah, very cool. All right. Well, Jeff, thank you for your overview. Now let's move to something a little easier to consume. Let's look at a demo. So Brian is going to show us a demo that he built using some of these technologies we've been talking about.
Yeah, so I work at AWS, and so we have all these tools that can help you get started. But visualizing that can be a little bit challenging, right? So I took an initiative with some of my peers to make a very lightweight demo to demonstrate how you can create better user experiences, right? More unified user experiences by embedding artificial intelligence capabilities into wherever your users are. So I'll share my screen in a moment, but essentially what we want you to envision in this type of a workflow is exactly what's already been described today. How can we take natural language input in a unified interface? So think of it like a chatbot, right? Take that information or a prompt that a user provides, and then orchestrate the knowledge retrieval information that's already in a data repository or a document. In this case, I'll talk about in the demo. Then orchestrate data analysis operations. Like Jeff mentioned, we want to not let the AI model perform mathematical calculations, but rather send that out to a geospatial processing tool. Alternatively, you could also connect to GIS systems. And then finally, what you'll see in the demo is how that user's prompt can control what the user sees on their screen. So let me share my screen and let me know when you can see it.
Yep, we can see it. It's green right now.
Yes.
There we
So
go.
this is Australia, right, on a map. And so what I'll do is I'll zoom into a part of Australia. You'll see Brisbane and Cleveland here on the screen, and I'm going to start sending some prompts. So I'll talk you through what's going to send. This first question is, what zones allow build of a granny flat? This is not something that a large language model naturally would know from its general purpose training. But by connecting it to a data repository, which has our urban planning policies, we can say, oh, low density residential zones have this information. And we can also reference where that information comes from with the knowledge-based retrieval. So there's those sources. You have more trust in the AI model that it's not hallucinating with its response, but it's manifesting that information in natural language. Then, I don't know if I can move this. Okay. This next question is, okay, great, I have this information. Now about that low density residential zone, can you tell me about what properties are in this area of the map? And so here, that natural language input can put markers on a map, give you information. It's controlling the front end, right? Through an agent that allows it to have that connective tissue from AI assistant to what the user actually interfaces with. So they want to know more information about this Abbeville, 26 Abbeville marker that they've selected. They ask a question, how many stories can I build here? And you'll see that there's a little bit of context that is shown in this user's prompt. Hey, this is what the user's looking at. Based on what they've selected, can you answer the question how many stories a land developer can build here? And again, natural language formatted, all of this is generated on the fly by the large language model. And the last thing that we have is one more feature of control. Think of it like generating maps or adding layers. So here we say, can you draw a 5-mile circle? And you'll see very soon that if we zoom out, okay, this is the radius of a 5-mile circle around this area. And we can use that to create very unique visualizations that might be helpful for other analytical processing that a person might want to do in an application that they manage. So the idea being embedding these capabilities where the users are can create transformative experiences for a lot of federal missions as well as other geospatial workloads.
So this makes it really approachable for someone that is not a GIS analyst, right? So someone that just wants to get information, they can talk to it in normal language. That's a really neat feature.
So I can let go of the screen share and give it back to you, Paul.
Yep. Sure. Okay, so that wraps up our panel. And now, are there any questions from the audience?
And Paul, maybe while audience members are queuing up questions, some of what Jeff and Brian just showed us, I think there's something that the audience might want to be aware of is there's emerging work in the European Union right now on a concept of something called data spaces. So we got a data asterisk for everything, right? But the data space is really the data lakes that Jeff was talking about, plus that policy and other regulatory information that Brian was highlighting when querying about the granny flat. And so this concept that you not just have a lake of data that you're going to dive into and work on, but the data self-describes what it was built for, what purposes it might serve, how you might use it in the future. And while that's very European Union centric at the moment, we do see a lot of US government organizations paying close attention to that and looking at trying to build common frameworks in our own infrastructures to have these, quote, data space concepts.
Yeah, that's bleeding over into all data, right? So we're getting a lot more advanced data catalogs at the moment as more of these AI capabilities come online.
Yeah, for sure.
So we've got a question. Are the presenters Coniag employees, or are they available to ask questions after this presentation? Some of us are Coniag employees, such as myself. But as Scott pointed out, he works for OGC, and our three other panelists are from AWS. Are they available to answer questions? Yes, they are. Please just reach out to me at this at my email or through Teams, and we'll get you connected up.
So
Okay.
Paul, maybe a question for you, since you
Sure.
have been asking all the questions. What role does Coniag play in all of this, trying to take these GIS systems and modernizing them? Do you want to elaborate on what you envision Coniag's capabilities to help the federal agencies there?
Yeah, so good question, Brian. So we implement GIS for many of our customers, right? That's our role. We're an integrator. So we help our customers adopt these capabilities and modernize capabilities. So we actually have one right now for the Navy where we're helping them move their Geographic Information System portal to the AWS cloud. We have others where we provide GIS analysts that use the Esri platform to build the most optimal layout for, say, a Navy base or an Army base, right? So the full scale of GIS is in our scope, and we can help the customers adopt these new things such as the cloud or AI implementations. The next question that I have is from David, and what LLM models are we using in an AI assistant? So Brian, do you want to talk to that one?
Yeah. So this was a lightweight demo to showcase how you can use Amazon Bedrock as a managed service in the generative AI space to give you that inference at the integration layer. And so in Amazon Bedrock, there's a lot of models available to you to switch out and change. There's actually a specific Converse API that standardizes the way that you would request information from the models. So you can interchange which model provider and which model identifier you're using. This specific demo was built earlier in the year, so it's using the Anthropic Claude 3 Haiku model. However, there have been later model releases since this demo was built that we can swap out and not have to change the connective tissue on the application layer. But because Amazon Bedrock provides the latest models as a configuration item, we can just change that identifier in the app code. I've not done that yet, though. So the question really is about empirical evidence in your testing. Which models do you want to use for the orchestration type workflows? Do you want to route certain prompts to other models because this is more of an analytical task with a more verbose response versus this is more of a factual response that we only need one sentence to answer. So those different decisions that you make can decide what models you send your users prompts to.
Great. Thanks, Brian. The next question is from...
To add on to that real quick too. So
oh yeah, sure.
The demo, that was like a RAG architecture. So a lot of the data you're looking for is already in a database. So Anthropic's Haiku model is kind of borderline what we would consider a small language model because it's just grabbing the data and essentially summarizing it, you would want to use something small like Haiku, again, being a small language model, and they're much more cost effective. So Haiku, I want to say, is what, like 10 or 20 cents per million. We say tokens, but basically words. Some of the larger language models that are, I want to say, what is it, 70 billion parameters or whatever, like some of the biggest ones, they can get up there to $60, $70 per million tokens or million words. So you're going from 20 cents per million words to $70 per million words. So it's, yeah, a big jump.
Yeah. We use it internally and it is pretty cost effective.
Yeah, Haiku's great.
Yeah. Okay. The next question was from, Narkisa from Mississippi State. Yes, we are interested in partnering with universities for R&D. So I will reach out to you. Thank you for providing your contact information.
Yeah, I was just gonna add on there, like there's an ask for like training. We do actually have a couple of workshops that we built that are publicly available that you could go connect to and run. I could drop a link in chat if that be of something of interest for people.
I think that'd be great if you drop it in chat.
Yeah, there we go. So there's 3, and the idea is each one increases in complexity. So the first one's really just Pro on AWS, the second one's Enterprise, and the third one is Kubernetes.
Okay, thank you. The next question is from David again. He asked if there was an architecture diagram. I think that's specifically targeted towards your application, Brian. Did you build an architecture diagram to go with that?
Yes, I was just making sure I was off mute. I can try to open it up really quick to showcase it's not the totality of the system, but it showcases how you might connect to. See if I can change my screen. If not, if I can't open it right on the fly, I'll be able to share this with you another time. Here, I can share my screen. Share screen. Okay, can you see? So actually, when we built this, our goal was to use as few of the Bedrock features to try to really understand why the Bedrock service makes it easier to connect these systems. So we have an API that receives the messages, stores it in a database, and then whenever a database event happens, we start in a model invocation process, right? And so in this Lambda function, it's actually using Bedrock just for the inference engine, not for its other surrounding capabilities that it makes a lot easier for the rest of the tasks. So essentially, Lambda becomes the model router, it becomes the tool provider, and then Bedrock just hosts the model's inference in this architecture diagram. And so what that allows to happen is when the Bedrock model, say, needs to invoke an agent, is what it's called an agentic workflow, to, say, calculate a geospatial distance between 2 points or a route between 2 points, we can go and use another service like Amazon Location Service to calculate what is the route between these 2 places, what is the place search that we want to do. And so again, it's not making the model do all of the jobs, it's just making the model the natural language interface for the user. And so that model conforms, understands what tools it has available, can go to Amazon Location Service, could go through agents to your other GIS systems. What's not depicted here is what Bedrock does offer out of the box as well as features. So Jeff brought up Bedrock knowledge bases. That's managed retrieval augmented generation. If you've ever set that up, there's a step-by-step process to do that. But knowledge bases makes it easy to get started and integrate your data sources for the purposes of doing knowledge retrieval from these models. And then Bedrock agents makes it easier to do what I just described as far as what is the chain of thought reasoning that a model might have before it starts to invoke these tool agents that then connect into the GIS systems. So hopefully that clears it up a little bit. I'm sorry I don't have a model that more directly addresses your, or a diagram that more directly addresses your question, but this is a little bit of a visualization there.
Brian, I'm curious just on your, have you done any much sensitivity analysis on the nature of these queries and how well they perform based on the type of person asking? And the question comes from a workshop we ran 2 weeks ago where we had natural language access to data. The people who were image analysts, former government or current government analysts, formulated really good queries and got good results. The folks in the same room who were software developers or data managers couldn't formulate a question to get an answer to save their lives. They were overly specific and got back that sort of, sorry, I can't answer that response time and time again. And we were kind of shocked at the sensitivity to the interface for some. It wasn't this particular tool set.
Right. So that sensitivity is largely driven by the configuration and system prompting that the application implements, right? So Amazon Bedrock allows you to create a system prompt in your agents. You can provide instructions to it. And so there's a lot of testing that needs to happen and quality assurance in that process to make sure that we are generalizing this capability for the broad set of users. And if you do have a small profile set of users, then we're going to specifically target what are they going to input in natural language and then do some acceptance testing. So if they were to actually use this, does it produce the results we need, or do we need to iterate and change what instructions we're providing our Bedrock agents or what system prompt we're providing our models? And all that is just a part of prompt engineering. So I don't know necessarily the sensitivity testing frameworks, if there's anything that helps with that, but it's definitely a process to make sure that your users and your application or service providers are meeting where they expect to meet.
Cool. That makes sense.
Part of that too is there are some parameters that can be adjusted. A lot of users like the RAG architecture because they're worried that these foundation models will hallucinate. So with RAG architectures, usually the hallucination is set to 0. Like if you don't know, don't try to make anything up. But that can be adjusted. That hallucinates. Yeah, sometimes you want it to get a little creative because sometimes it's correct when it's coming up with these creative answers. So yeah, that's part of that, one of those configurations that Brian mentioned.
Yeah, and internally, for our system, we have what do we call it? Tested or condoned applications, where we've built a good quality RAG for the application, really good prompts, and it's been tested, dozens or hundreds of times before it gets condoned as one of the applications you should use. We also have a bunch of sandbox applications that vary in level of quality.
The last thing I'll say is that if your application has been built with a specific expectation of what the users are providing, maybe provide that as training materials for your users or operating procedures, right? If you want this type of an output, this is the input you can provide that will yield that. So that can help upskill or transform the thinking that the actual application user does. All right, I think we're out of questions, Paul.
Yeah, well, great conversation, everyone. Thank you, everyone, for coming to join and listen to us. And thank you for all the panelists for coming together and presenting the information. If you have a GIS problem you would like to solve, reach out to me. I'll pull everyone together and we'll see what we can do to help you. Everyone have a great holiday.
So,
Thanks, Paul. Thanks all.
thanks, Paul.
Thanks.